Welcome to this explainer. Today we're diving into TXENT, which is a system that is fundamentally transforming how we handle incident response. Listen, if you've ever been on call, you know exactly what I'm talking about. The absolute soul-crushing pain of being jolted awake at 3 a.m. by some generic alert that doesn't actually tell you what's broken. Well, today we are exploring how TXENT changes that entire paradigm by essentially giving your observability a memory.
You know, there's a quote that perfectly captures the hidden threats lurking in modern architectures. It goes, "The most dangerous incidents are the ones that look routine on the surface." And it's so true, right? In these complex, distributed microservice environments, a massive cascading failure usually masks itself as a simple, everyday error. If your system is only looking at the surface level, you are absolutely going to spend hours chasing ghosts while the real fire burns down your infrastructure. So, we have to ask ourselves, why do traditional observability tools fail us when it really matters? Why does that 3 a.m. alert leave us totally blind to the root cause? The answer is surprisingly simple, honestly. Traditional tools lack context. They just react to static thresholds. So a CPU hits 90% or a database times out and an alarm rings. But the system has no earthly idea why it happened or how it connects to the broader system topology. It wakes you up, sure, but it does not help you solve the problem.
Here is our roadmap for today's explainer. 1. Beyond threshold-based alerts. 2. The 4-layer memory architecture. 3. Firing the kick mechanism. 4. Autonomous agentic investigation. And 5. Powered by Splunk Enterprise.
Okay, Section 1. Beyond threshold-based alerts. The problem with passive monitoring.
The old way of incident response is entirely passive. It's really just a symptom reporter. But TXENT? It acts more like an artificial intelligence colleague. It evolves the whole concept of incident response from just waking you up to actually solving the mystery for you. It doesn't just pass the buck to a tired human engineer. Instead, it actively remembers historical patterns, it reasons through the current data, and it investigates the topological signatures of the incident. It's a real game changer.
Moving right along to Section 2. The 4-layer memory architecture. Giving observability a brain.
Looking at the TXENT architecture, we have this central orchestrator dynamically routing information. It connects the cognitive memory layers, which we're going to break down in just a second, with the active components, namely the kick mechanism and the investigation agent. And foundationally, underpinning the whole shebang, everything is deeply integrated with Splunk Enterprise. It creates a complete, self-contained reasoning loop.
To make sense of this memory, notice how it progresses from raw logs in Layer 1 all the way up to senior SRE wisdom in Layer 4. Layer 1 is your surface memory. This uses incredibly fast vector search for raw logs and telemetry. Then Layer 2 is the associative graph, which maps out exactly how your services are connected. Like, it knows that your payment API talks directly to your Redis cache. Layer 3 is where it gets really smart. It contains 7 specific observability pattern signatures, things like cascading failures or network partitions. And finally, Layer 4 holds operational archetypes. That's the kind of deep operational wisdom a senior engineer builds up over 10 years of late-night incident response.
All right, Section 3. Firing the kick mechanism. Challenging assumptions.
I want you to think of this kick mechanism like a seasoned detective finding a glaring contradiction in a suspect story. This is what turns a passive dashboard into an agentic system. The kick mechanism is constantly watching the incoming stream of alerts. When it sees an alert, let's say a database timeout, it doesn't just accept it at face value. No way. It compares that surface symptom against the deep structural patterns in Layer 3. If the symptoms are pointing one way, but the structural pattern points another, the system detects a semantic contradiction. And that contradiction, that is what fires the kick. This exact logical flow is absolutely crucial because it prevents you from wasting hours chasing down a database issue when, say, Redis memory is actually what's exhausted. Imagine step 1. You get a database timeout. A naive system just escalates a database failure, right? But in step 2, TXENT compares this to Layer 3. In step 3, it realizes the topological footprint actually matches cache saturation, not a database failure at all. The database is only timing out because the cache sitting right in front of it is dead. So in step 4, it fires the kick to investigate the true upstream cause.
Point 42 TXENT literally uses math to calculate the distance between what the surface alert says and what the system's deep structural memory knows. If that mathematical distance, the divergence, exceeds point 42, the system officially flags that the alert is just a downstream symptom and it is time to wake up the AI agent.
Section 4. Autonomous Agentic Investigation. Gemini AI meets Splunk.
So, once that active incident investigation kicks off, the agent starts querying logs and building an evidence timeline in literal seconds. During a major event, you might see the kick firing at a massive 91% contradiction, and as the investigation timeline populates, the system is autonomously analyzing the dependency graph, executing live queries, and clearly identifying Redis memory exhaustion as the true root cause. And it does all this while a human on-call engineer might still be pouring their first cup of coffee. Behind the scenes, this autonomous investigator relies on the Gemini 2.5 Flash LLM, giving it incredible speed and reasoning capabilities. But it's not just hallucinating or guessing, it actually executes real Splunk processing language, SPL queries, to fetch hard evidence. It traverses that layer 2 knowledge graph we talked about to pinpoint the upstream culprit, builds out a chronological timeline, and then, best of all, produces actionable remediation steps that you can execute right there from the dashboard.
And this intelligence directly translates into real-world results on the target device. You can have a critical state where the payment API, the cache, and the database are all flashing red, with API latency spiking by over 400%. But then, after the agent's recommended remediation is executed, like automatically scaling the Redis cluster, you see the system return entirely to a nominal, healthy state. All the services go back to green, and latency flatlines back to normal. It proves that TXENT doesn't just point out problems, it guides you directly to the resolution.
Finally, Section 5, powered by Splunk Enterprise, the indispensable engine. Gemini AI might be the brilliant navigator here, but Splunk Enterprise is absolutely the high-octane engine providing the raw, unfiltered truth across 3 main integrations. First, the Splunk REST API allows the agent to fetch real-time events. Even more impressively, it utilizes the Splunk MCP server, that stands for Model Context Protocol, which exposes Splunk's native powerful search tools directly to the LLM. And thanks to the HTTP event collector, TXENT can seamlessly push its own findings and timelines right back into Splunk, ensuring a completely bi-directional flow of operational intelligence. The takeaway here is simple. Observability needs a memory. By combining Splunk's frankly unparalleled data ingestion capabilities with TXENT's memory grid, we are completely revolutionizing operational awareness. You stop fighting the symptoms and you start resolving the actual root causes. The days of reacting blindly to isolated spikes on a dashboard, those are essentially over. So I want to leave you with a question to really reflect on. What if your observability system didn't just wake you up, but actually solve the mystery before you even opened your laptop? Imagine opening your computer during a major 3 a.m. outage, and instead of a blank search bar and panic, you were greeted with a fully investigated timeline, hard evidence, and a single button to execute the fix. That is the incredible power of giving observability a brain. Thanks so much for joining me on this explainer, and keep questioning the surface.